Okay, today's science video is going to be a little bit shorter because you've got an assignment that might take you a little bit more time, a little bit of research here and there. And I think you guys have done conductors and insulators before, if I'm not mistaken, in like grade 4 or something. So some of this will be review, but what we want to understand is how conductors and insulators work with the particle theory of electricity. So a conductor is a material that allows electrons to move through it fairly freely. We say that these materials kind of quote unquote hold their electrons loosely, which means they don't have a great hold on them. There's a massive attraction to those electrons, so they can get peeled away by other materials fairly easily. So when you've got a balloon, right, and you rub it on your hair, electrons are being transferred very easily from your hair to the balloon. So you would maybe say that your hair is a better conductor than the balloon is. It's not necessarily saying your hair is a great conductor, but it holds its electrons more loosely. That's why it's the one that transfers them to the balloon. Excuse me. Insulators are materials that don't allow electrons to pass through them very easily. And these materials have what we call a tight hold on their electrons. So over here, you'll notice we've got some electrical conductors like silver, gold, copper, steel, and seawater, and electrical insulators like rubber, glass, oil, diamond, and wood, dry wood. And you'll probably be familiar with most of these. The tendency is that metals tend to be better conductors than other things. That's kind of our rule of thumb. There's a really good table in your guys' textbook, page 308. I think it's table 9.1 if I'm not mistaken. And generally metals are good conductors, and things like wood, paper, rubber, and plastic are good insulators. But all of this is on a continuum. That's why I brought up the idea that your hair, although it's probably classed as an insulator, is pretty good or a better conductor than something like a balloon or something like wood. So let's take a look here. We've got good conductors: aluminum, copper, gold, nickel, platinum, silver, and tungsten. Copper is a really, really good one. That's why we use it in a lot of wiring. Gold also. However, gold's a lot more expensive, so it's not used as commonly as, a wired conductor. Ferroconductors. So this is things that will transfer an electric charge: silicone, carbon, the human body, humid air, nichrome, salty water. And insulators: cotton, glass, paper, plastic, porcelain, rubber, and water. Pure. We're going to talk about that for a second. So I have an entire slide on water. Uh, Pay attention to that. Water is listed in your textbook as both a conductor and an insulator. And at first, that seems like it doesn't make any sense. And most people think of water as a conductor, and usually it is. But pure water is slightly different. So if you take a look at this little picture here, there's something called deionized water, and all it has in it are H2O molecules. Most of the water that we deal with, tap water, water coming out of a hose, all that stuff, or even water you find in a pond, has ions in it that are minerals or other molecules other than H2O, which have charges on them. So calcium, I know there's some chlorine in our water, there's fluorine in our water, there's all these little trace elements of salts and other molecules. And those molecules are what actually transmits an electrical current very quickly. Those are the ones that are transferring electrons very quickly. So when you see, in a movie or something, an electrical wire goes into a puddle of water and electrocutes the bad guy or the good guy or whoever, right? That's the stuff that is transferring that electrical charge, those other ions in the water. I saw a really good quote when I was kind of doing some reading about this, where they said, although water, pure water is a fairly good insulator, it doesn't take much of a current to ruin your day, which is a really good way of thinking about all of these. Although these are insulators, I still wouldn't take like a glass rod and touch it to a high voltage electrical wire, because that's scary. It's probably still going to do something bad. So don't Don't take any of this for granted. Electricity can be dangerous. Pure water, it's not, you're still going to get a charge out of it if the current is strong enough, and it doesn't take much current for your body to get messed up. That's why human body is a fair conductor. And we're going to talk about the electrostatic series to finish off here. An electrostatic series, excuse me, is a chart basically that puts things on this continuum that we've been talking about. It says, what's a better conductor? What's a better insulator? So materials like human skin and rabbit fur have a weak hold on their electrons. They generally donate the electrons. So you'll notice here it says weaker tendency to gain electrons, which means stronger tendency to give electrons, or a weaker hold on their electrons. Things like polyester and ebonite have a strong hold on their electrons. They'll generally gain electrons. They don't want to give anything away, but they will take some. So what happens if rabbit fur is rubbed on a balloon? We take a look at rabbit fur. This is how we use an electrostatic series. We take a look at rabbit fur. It's up here. And we take a look for balloon, rubber balloon, right here. So if we make rabbit fur and a rubber balloon come in contact, rubbing them together, the rabbit fur, so this has a weaker tendency to gain electrons, and thus a stronger tendency to give electrons, is going to donate electrons to the rubber balloon. So since this one is on this side of the electrostatic series, it's going to give electrons to the balloon. That's what this arrow is kind of showing. It's like as you go down, this thing will give electrons to whatever's down here. And what about silk rubbed on paper? So if we look at silk and we look at paper, they're actually right beside each other. So technically silk is going to donate electrons to paper, but it's not going to donate electrons nearly as quickly or in as large a number as rabbit fur would donate to a rubber balloon, because these are so far away. I believe your guys' textbook has an electrostatic series in it as well. However, there are a ton that you can find online. And this is something I suggest doing when we are doing today's, or today and tomorrow, I suppose, doing that small assignment. Find a bunch of different electrostatic series because all of them have different stuff, right? Everything in the world can be put on an electrostatic series, and there is no one electrostatic series that you can find anywhere that has everything, because that would be too much stuff. So I really suggest looking at quite a few different ones. Take a look at your textbook. I'm pretty sure it's in there. Maybe it's not, though. They might have a chart. Like they might just have a chart like this. But this gives you an idea of like this is going to be more likely to donate electrons than the insulators are. That's kind of how you would put uh, conductors and insulators onto an electrostatic series. The conductors would be up here. Insulators would be up here, or down here, excuse me. So take a look online for different electrostatic series if you need. And that'll be it for today. Cheers.